Welcome back, scholars. Today we're going to look a little bit more at those sum and difference formulas from the previous lesson. This time, our focus will be on verifying various trigonometric identities. Let's get started. We'll start over here on the left, and our goal is to prove or verify a couple of cofunction identities. Recall that an identity is true for all angles defined in the domain of a given function, and that to verify an identity means to prove or to show that it is true. We usually accomplish this by transforming the left-hand side of the equation to look like the right-hand side. So, on the left, we have cosine of pi over 2 minus x equals sine of x. We're going to use the difference formula. So, on the left, we have cosine of pi over 2 minus x equals sine of x. And we're going to use the difference formula for cosine to show this. Notice how the left-hand side already takes the form of cosine of u minus v, so we'll just expand this on the left side using the difference formula. That will be cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. We'll substitute exact values wherever possible using coordinates on the unit circle as a reference. This gives 0 times cosine of x plus 1 times sine of x. Using the zero product property, I know anything times 0 is just 0, so this entire expression simplifies as the expected value sine of x. Now let's hop over to the right. This time we're verifying sine of pi over 2 plus x equals cosine of x. Note that the left-hand side takes the form of sine of u plus v, so again we'll expand this out using the sum formula. Once again, substitute any known values and simplify as much as possible. Since we are again multiplying by 0, this time, in our second term, this entire expression simplifies to cosine of x. Let's verify a different identity. Once again, I'm going to use the sum and difference formulas to transform the left-hand side to look like the right-hand side. I've got a product of a sum and a difference here, so I'll end up using both formulas. Let's start on the left-hand side. Note that I've highlighted the first factor in blue and the second factor in green. I'm going to expand each using the sum and difference formulas respectively and highlight the expanded expression in their matched colors. Now, this is pretty tricky to spot because the expression is pretty lengthy, but this is actually the a plus b times a minus b factor pattern, which is the difference of two squares. To help you see it better, I'm going to redo the color coding, and this time I'm going to highlight the a term and the b terms of the binomial in the factor pattern so you can spot it better. Recall that this pattern expands to a squared minus b squared when you FOIL and combine like terms. So I'll go ahead and write this as cosine squared of x times cosine squared of y minus sine squared of x times sine squared of y. Next, I'll use my Pythagorean identities to make a couple of substitutions here. Remember, whenever I see squared functions, I'm always thinking about those Pythagorean identities. Highlighted in purple, we have the two substitutions that I've made going into this next step. Last, I just need to distribute my multiplication, combine like terms, and simplify. Our final expression will be cosine squared of x minus sine squared of y, which is our right-hand side from the identity. We have just two more to look at. On the left here, we're going to simplify this expression down to a single term. Note that the cosine expression is already in the form cosine of u minus v, so we'll just expand it out using the cosine difference formulas. As we did before, we'll substitute any known exact values and use the zero product property to simplify. This time we'll have just the single term expression negative sine of x. On the right, we have a tangent expression taking the form tangent of u plus v. Using that tangent sum formula, we'll expand it out. Note that tangent of 3 pi is equal to 0. Simplifying both the numerator and denominator, we end up with just tangent of x. That wraps up our second look at sum and difference formulas. Next time, we'll look at ways to solve trig equations using these formulas. We'll see you then.